So our next presentation is investment opportunities in high-performance buildings. Mr. TSAKIRIS is the current president of the Hellenic ASHRAE chapter, and he's also an engineer working on ZEB Energy. So, Mr. TSAKIRIS, thank you very much.
Hello. I would just like to say one word regarding the previous answer of yours. United Arab is not quite a democratic state, and I will start. Yeah. And we can talk about it. You know, I have the opportunity to present today instead of our CEO of ZEB. I will be extremely fast. Okay, there are more hot issues that we will discuss today and more hot reservations with legendary, I would say, presenters that we have today here. So, there is the issue for the high-performance building opportunities. A main issue is the reduction of energy consumption. The design process is a very important part of this, and we need to establish a new kind of design that up to now was a very strict process, with normative steps, that we need to go further from that. Another issue that we need to have in mind in order to assess performance is the return of investment. There are financial ways to check that. There are also social, you can check it with many ways. We will focus a bit, roughly and very fast, on systems and services that help to address the performance of buildings that have an important effect on the return on investment from various aspects. One thing we have to consider is high-performing mechanical systems. We're talking mostly about the HVAC here, and it's very important to address it through a life cycle cost analysis, find out what the different scenarios of systems, what are the effects of the various scenarios of system establishment on the life cycle costs of a building. Check it within 15, 20, 30 years, 50, what's going on with this equipment. We should always take into account the partial loads efficiency. In Greece, as far as I know, most of the buildings I've seen, and I've seen quite hundreds, most of the time they're operating in partial loads. So when you just focus on designing for the peak, you lose all the efficiency on the partial loads. One has to see how this issue can be addressed. We'll see ways afterwards. And of course, there is always the issue of higher capex versus higher efficiency during the life cycle of the building. This is not always the case, we have to say, when we are designing high-performance buildings. Energy modeling can give a solution and can inform adequately all these issues that we discussed here, and I will go throughout the presentation to the issue of energy modeling. Renewable energy systems, I will not stick to that. They are well established. We can find ways to put them. Personally, I believe that photovoltaics will be everywhere in 30 years. Okay, I don't know, perhaps we'll have on the streets photovoltaics. We will certainly have on the facades that are not, of course, the most efficient thing to put them, but I think we're going to go there. I take my risk and my chances for that. It's very important to keep that in mind in order to move to net zero buildings, actually. A very important thing is the envelope. There is an integrative process, well established under ANSI, ASHRAE, Architects, American Institute of Architects, LEED. One should check how the elements of the envelope come together early in the process of designing and a building. The window-to-wall ratio is a factor that works very differently in different climate regions and from building to building, and affects the loads, affects the peak loads, affects the partial loads, everything. The window performance, I'm not speaking about the envelope, about insulation, because things are quite clear there with the usual regulatory procedures. The window performance is a big issue. Most of our colleagues consider only U, and I have to inform you that U, it's good to be high in the cases of Greece in our specific climate, and we have to focus on G, on solar heat or solar heat gain coefficient in order to have the effect that we want. Low U can be a problem in many cases for the window with a frame in Greece. In platinum buildings, we have allowed them to move to higher. We either had to tell them move to higher or stay somewhere between 1 and 2.5. I think ASHRAE 90.1 Chapter 5 addresses well this issue on some initial values that we should have in mind. This is a very big issue and we cannot really discuss it here. Wall and roof insulation is very important. Wall, we're doing fine. Roof, it's always a question. And on the ground level slab, it's always a question how we should treat it. We should never forget during the envelope design or question setting procedure to see what we can do with daylight and also adjust the visual performance of our windows. Let's not forget that, as far as I know, the envelope is perhaps the most important part for enhancing thermal and visual occupants' comfort. Performance is another thing, but we can address it very early in the stage and have huge impacts that it's very difficult to address them throughout the life cycle of the building. Then we go to the plug loads. In high efficient buildings that are now designed in Greece, we see that because envelope is quite well addressed, the performance of the HVAC system is well addressed, we have high equipment loads. One should do a special. Nobody really cares about them. There is not someone who really cares about that during the design procedure. Yeah, I'll put this kitchen, I'll put this thing, I'll put these servers, Nobody cares. There are cases where the plug loads are more, in high performance buildings, the plug loads can be more than 40% of the energy consumed of the building. Okay, in high performance LEED platinum buildings, let's say, in this case. So it's an issue, it has been addressed in other presentations in ASHRAE, and this is an issue we should start working on. I will not stick to that now. So, okay, we've done everything, everything is high performance, we did our modeling, we've done everything, okay. We are fine. No, we are not fine. We have to monitor the building, we have to put the algorithms, the sequences of operations for the specific machines that we have put on the building, for the specific setting of the equipment that has put, and we need to see if they are well, if they're performing well. So, data recording, a BMS with energy management features is essential. Believe me, now I had the case, we've done a very, we've changed some chillers, they were old, we've put the new chillers, optimized the sequence of operation, everything. We had the meters on, the pumps were working, the internal pumps of the chillers were working there. It was 3 kilowatts, okay, but it's 3 kilowatts, nobody would know in a new system, okay. I don't know what will happen after 6 months if I go back. Okay. Nobody really knows. Believe me, things will be much worse. Okay, so a month after the commissioning of the system. So the metering equipment needs to be targeted. One should know where to put that. There should be adequate hardware. We've seen hardware not connected. Okay, it should be integrated thoroughly, and it should be also the software and the sequences of operation should be well designed. Records. Without records, you cannot go back. Okay, and the system should be automated. We don't need to put. Of course, we should have. It's a good thing for the occupants to be able to fix their everything, the lighting, their thermal comfort, everything. But you press a button, it can adjust, but we need central automation. Of course, you can go around the system, but automated everything in order to work according to the system. And this thing should be commissioned again and again. There are also other things that I'm talking now. Alarming. Not only alarm, usually now. What I say, do we have alarming? Yes, we have alarming. Here the fan is broken, there the compressor, I have an alarm, I don't know what it is. Okay, something is broken. We need to have energy alarms. If someone should sit down, okay, an expert, and check and put some alarms when some things are not working properly or operating properly. All these are from a very high level point of view. Okay, when we go down, this thing for the alarming and setting it from an alarm, setting an alarm and having a solution, it's a 6-step process. I will not go into that. So let's go to the services. Energy modeling. It can inform also how a building is working now, a built one. How is it working? You can go put your meters, take your data if you have, whatever data there are. You can calibrate and see what's going on and what are the operating efficiencies in various situations. The same thing can happen to a new building. The partial loads I've also talked again. You have a very good view. I don't know if one can really understand how important it is to have the partial loads. Okay. I was very stressed the other days, because I could not easily address the partial load. With energy modeling, this is very, very well documented. You can also have a very important thing is that it might reduce the capex, the energy modeling. Why? When we size the system, most of the time we size the system for the worst conditions, climate and occupancy conditions, for the whole building. In a large building, 10,000 square meters, 30, 200,000, I don't know, 7, 5,000, there is no case that the whole building will need cooling at its peak or heating at the peak loads. So you find out that the peak loads are only, you know, at the part of the building, and the other part of the building might need heating or instead of cooling. Okay, so there are many cases where modeling can create also capex reductions. This is very important to have in mind. Of course, we can assess HVAC control strategies with the system. Okay, a large issue. We will not go there. A very important thing that LEED has not addressed, as far as I know, but BREEAM quite addresses it, is the future climate performance. In an energy model, in a modeling situation, you can insert, you can go from the IPCC medium scenario, take your DSU file and see what's going on after 15 or 50 years to the building, if it performs well or bad. Commissioning. LEED, I'm going very fast now. LEED had created a very good thing. Many buildings in the US are not following LEED, but they follow the commissioning project, the commissioning process. The owners understood the value of this process, and they follow the commissioning. So we have to keep that in mind, how important it is to receive a proper, how the owner knows that their equipment are working properly and how they can monitor this performance throughout the life cycle. I'll go, we should always, when we discuss about performance, we should not forget the internal, the thermal comfort. In all of the cases that I know, improving energy consumption, it means having better thermal conditions. I don't know a case which this is not true. Here is something that I really like. You can see how it works if you have appropriate monitoring, how you can move between two paths. The one path is of the investment in buildings in steps, larger investments, and incremental investments. Okay, the gray part is the part of the return that one loses if he does not monitor the building, and if he has not, if he doesn't have a proper strategy and operation to monitor all this stuff. So, if we do if we have appropriate processes, okay, for making these decisions that we've talked about, we get increased asset values. The real estate owners know this thing very well, and this is why most of them are following LEED, BREEAM, whatever green certifications, and they're considering very, very seriously. The reduction of operational costs, we all know about that, I am not going to. The buildings are more healthy and people inside are more productive. Believe me, anyone can have his own opinion about the certifications and stuff. The good buildings, if you go inside, you feel the difference with a building that is not well designed. You feel it. And all these are creating higher productivity, less absenteeism, everything. We have to go further than the codes, especially in Greece. I think the ones who work with Hellenic understand the issue that I have addressed. And there is always the economic case for resilient design that takes into account the higher temperature, the risks, all the costs that are related with the climate change. both the effects of the building on the environment and the effects of the environment in the building. How a different climate will affect the building and what are all these risks. Thank you very much.
President, thank you very much for your immaculate time management. So, do we have time for one or two questions, maybe? One only, or only one? Okay.
Thank you for your very nice speech. Just only a question and very short answer. You mentioned before about the black loads in the building. What is the black load?
Black loads.
Black.
Black loads.
Black loads. Yeah.
Everything that goes to the black.
To the black, because they hear black.
Oh, no.
Okay. Because the first time that I hear black.
Sorry for my English, Vasilis. Sorry. Pardon me.
If it's a quick one.
You spoke for data acquisition with monitoring all of these things. But as I know, we do not have any standards for this. So everybody is putting his own. How we will handle this?
Talk to an expert. Talk to an expert.
If I may, ASHRAE has standards for measuring and the certification protocols. There are standards for that. We've done. I have personally done.
There are measurement and there are measurement protocols from ASHRAE for sure.
Yes.
But so one should start from there. What does he want to do? Okay. In order, and what does he want to measure in order to do something? This is well documented, but you have to go to the experts. Okay, who are the experts? You can check the available certifications for persons that are also from ASHRAE and from other organizations. I don't want to talk about myself, and move from that point on.
Please take one or two.
Thank you very much.
Thank you.